welcome to Jitesh classes. This is current electricity part 5. Okay, today this is not a live class, it's a live premiere. If I'll ask a question in middle, I'll wait for some 30 seconds, and at live premiere I will see who are saying answers. Okay guys, and today we'll discuss about semiconductor resistivity and conductivity, means on temperature dependence. Okay, and also we'll talk about mobility. Okay, we'll talk about mobility. And next, this is a question, IIEEE question. We'll talk when we'll complete this. After completing this one, after completing that topic, we'll discuss this question. Okay, guys. And next, share the video. You may know who are preparing for JEE and NEET. You may know even 5 to 10 members. You share that video. This is helpful for them and who are preparing for boards. Okay, coming to our topic, we will also recall what we have talked in the last session. And guys, sorry for the inconvenience in last session due to the technical error, like due to that slow Wi-Fi, that video is not proper. After that, after 3 to 4 minutes, the video is good. Okay, you can watch that. And now we'll discuss, we'll once recall that what we have discussed about. First, this mobility, once we'll recall drift velocity one also, because this mobility is depending upon drift velocity. Drift velocity Vd is equals to minus E tau by m. M is electron mass, E is that one. E is charge, and this one charge means electron. E is equals to say 1.6 into 10 to the power of 9 minus 9 coulombs, and E is the electric field. Capital E is the electric field, and T is the tau, relaxation time. Okay, we have already discussed about it. And another one formula, J is equals to NeVd. Okay, this one, J is equals to NeVd. And also another important formula for this one is sigma E. J is equals to sigma E. Okay, these are helpful today. And another one, we have also what we have talked in the last session, recalling that. First we have recalled the last chapter in the last session, and now this one, what we have discussed in last session. It is first, R is proportional to L square. When the wire is stretched, conductor wire is stretched, then what happens is the R, even after stretching the wire, the L square is proportional to R. Resistivity, and resistivity is also proportional to 1 by area square. Okay, and it is proportional to R is proportional to 1 by R power 4, the radius, means the cross sectional area radius. Okay, these we have all discussed. And also we have discussed the temperature dependence. It's an important formula we have discussed. Rho at this rho is at a temperature. When a temperature is increased, this is the rho, means this is the or R, this is the resistivity, and R naught is at a relative temperature, means reference temperature, frame of reference. That reference temperature is R, and 1 plus alpha into that theta, means that temperature. Okay, means this temperature, change in the temperature. Okay, delta T, alpha delta T, and alpha is the temperature coefficient. Okay, alpha is the temperature coefficient. And alpha units, I forgot to say this one. Alpha units is this Celsius per Kelvin. Okay, this is the thing. These are the important one. These units. Okay. Now, similarly for resistivity, this is resistance, resistivity rho. Okay, now semiconductors. Okay, now we'll talk about semiconductors. In semiconductors, we'll take a example of semiconductor. Silicon. or like this bond. We'll take up silicon bonding, Si. This is a silicon bond. And what is the electronic configuration? Last 3s2 and 3p2 will be remain. Means the last we are taking the last one. No need of doing the complete electronic configuration. And these two electrons are there, no valence electrons. These two electrons will be shared here. Shared, okay. Two electrons will be shared. When what happens? When the temperature is applied, what happens is the electron, there is a covalent bond between those two electrons. So due to that temperature, the electron, the covalent bond will be breaked. What happens when the covalent bond will be break? Means one electron will go outside, means it will move. Then what happens? The number of free electrons is changing, means the number of free electrons is increasing, okay, is increasing. So here, this is a semiconductors lesson. We'll talk more depth, but this one just an idea about it, okay. The electron is jumping, one electron is going into the free electrons. So what happens here? Empty space will be formed. Then that is a hole, okay. Here, so we can say that in semiconductors, the electrons and holes are the mobile charge carriers, okay, are the charge carriers. Understood? See, if this is an atom, we are not writing all that electrons in that. This is an electron, valence electron. See, if this electron goes from this side to this side, see, first this electron will go due to the breaking of covalent bond. Then what happens? It will become empty, and this electron will come here. So this electrons are moving in this direction and the holes are coming in this direction. So the electric field in the semiconductors will be in this direction, okay. That is an idea, small idea about this one, holes. So holes and electrons are the charge carriers. And here, due to that temperature increase, the electrons, number of electrons increase. So the conductivity, what is conductivity? We got that conductivity Ne square tau by m, no. This n, if this n increases, this conductivity also increases. And if in case of resistivity, m by Ne square tau. If this n increases, this resistivity decreases. Okay. In semiconductors, then if this conductivity increases, what happens? The current also increases. The electric current also increases. Understood? In semiconductors, what is the thing is, when, okay, in semiconductors, when the temperature is increased, when at a temperature, certain temperature, when it is increased, the conductivity is also increased, but the resistivity is not increased, okay. There is a question on that. By increasing the temperature, the resistivity in a conductor and a semiconductor, what happens to that, okay. Now I am giving you 30 seconds. I will see in the live chat of that live premiere. Okay, I am giving you 20 seconds. Okay, so see, this is an IIEEE question in 2002, I think. IIEEE question. In those days, IIEEE is also equals to JEE. Okay. Now, what happens here? The resistivity in a conductor, normal conductor, what happens? The electrons. See, if the temperature increases, the relaxation time decreases, but the electrons does not more increase in the. Those depends on the metal. So it does not increase. The resistivity the resistivity will increase. Listen, in electrons, in normal conductors, what happens is the there no, these if the temperature is increased, the relaxation time decreases. So the relaxation time is directly proportional to the resistivity. It is directly proportional to the conductivity. So conductivity decreases, resistivity increases. In semiconductor, now only we have discussed that resistivity decreases. Okay, so here for normal for semiconductor the resistivity decreases. For normal conductor the resistivity increases. So the answer is this one. You can do it on your own. Now mobility. Before mobility you should think what is pushing the means due to what the motion is undergoing. Due to what the charge carriers are moving. Means the power source, the battery. Due to that battery, the battery is applying some energy. It is providing some energy. Due to that energy, the motion in contact with the charge carriers or electrons means due to the contact with the motion, then those will be pushed. Means those will supply energy. Supply current. And here these are called, now after the contact with motion, those are named as mobile charge carriers. And the mobility is the property which says as how easily the mobile charge carriers are moving. Okay, that says us. Now mobility, mobility only. The definition, how the definition is said is drift velocity per unit electric field is called mobility. Means mobility is denoted by mu. Okay, mu is equals to drift velocity per unit electric field. Means Vd by E is electric field. Okay. Now before going to that, we'll see a simple relation. The relation is J is equals to sigma E, and also J is equals to NEVD. So by equating this both, sigma E is equals to NEVD. Okay, and this sigma is NEVD by E. I written apart. So this Vd by E is the mobility, and sigma is Ne mu. Okay, we'll see some more about it. See, first explanation of mobility. What is mobility means? If this is a conductor, see, it is connected to a battery of voltage, potential difference, potential difference. See, if 10 voltage is supplied, 10 voltage of current is supplied, then what happens? See, 10 voltage is provided, then what happens? The drift velocity, those are moving with the velocity. No, drift velocity means, drift velocity, what we have learned, due to that electric current, they are getting continuously pushed and they are getting continuously collided. Before that they are pushed. No, due to that push, see, if at 10 voltage some drift velocity, and 20 voltage some drift velocity, means it is differing, it is varying. So then we can say it is depending upon the electric current, and the mobility is the property which says is how easily they are moving. No, here coming to this equation, coming to that formula, mu is equals to Vd. No, what is Vd? Mod Vd. Mod Vd means it is positive. E tau by m by E. This E and this E will get cancelled, and mu is E tau by m. E tau by m. This is one formula. Okay. This E, we know those constants. No, mu is E tau by m. Okay. Mobility is saying how easily that charge is traveling. Okay. And now here sigma is equals to Ne mu. And for holes, semiconductors, semiconductors what happens is this sigma will be E into NH, like holes plus electrons. This is for semiconductors. We'll talk about it in the chapter of semiconductors. Okay, this is mobility. What is mobility? Drift velocity per electric field, unit electric field is called mobility. That is, mobility is E tau by m, and the mod Vd by E, and this relation is this is also an important relation, that is sigma is Ne mu. That's all for today. We'll meet soon with the next video, tomorrow or day after tomorrow. Okay, the continuity is important. You should see up till end, then only you'll understand what is the concept. Okay, and share the video if you like my explanation. Like, comment, and share the video, and subscribe. And share who are preparing for NEET and JEE. It is helpful for them. You know, minimum 5 to 10 members you may know who are preparing. Share to them, and say them also to share, and also subscribe to my channel. Don't forget. Thank you.